While trying to build a best model, we tend to add so many variables, we tend to derive the new variables, we tend to add so much of data, and sometimes to build a very optimal model we might even drop the variables. So how do we improve the model? By adding new independent variables, or by deriving new variables, or by transforming? Or sometimes what we want to do is just simply drop few variables, even if we have to reduce or even if we lose out some of the accuracy, it's fine. Maybe instead of building a model with 200, 300 variables, we want to build a model with just 50, 60 variables or maybe 20 variables and have the best accuracy possible. Have the most top impacting variables and have an accuracy of 80% rather than having 200, 300 variables with an accuracy of 85%. So how do we build, if we have several models with maybe say same accuracy levels, how do we choose the best model? How do we choose the model that is best suited, or how do we choose the optimal model for a given set of parameters and for a given accuracy level? So if there are multiple models M1, M2, M3, how do I know whether M1 is the best model for my data, M2 is the apt model, or M3 is the apt model for my data? That can be decided by looking at AIC and BIC values. AIC, Archaic Information Criterion. So AIC, BIC values of a given model, standalone values of AIC or standalone AIC has no real use. It is something like adjusted R-square in linear regression. So when you have 2-3 models, you can look at their AIC values. The model with the least AIC value is the best fit. What exactly is AIC? AIC is an estimate of information that is lost when a given model is used to represent the process that generates the data, or simply AIC is the information lost while building the model. So you want to lose least amount of information while building the model. So if you have two models, model 1 and model 2, fairly comparable accuracy between them. Let's say model 1 has 84% accuracy, model 2 has 85% accuracy. You want to choose the best model. You want to choose a model because model 1 is built on 20 variables, model 2 is built on 30 variables. You want to know which model you want to go ahead with. Then you would choose the model that has least information lost. Based on AIC, you can choose that. You can look at AIC, the model with least AIC, that is the model with least information lost, is the best model. AIC formula includes maximum likelihood function and the number of parameters as well. So if you have multiple number of parameters, if you have too many independent variables and for a given accuracy you want to choose the best model, you can look at the AIC. AIC is information lost. The way we use AIC is, if you have 2-3 models with the same level of accuracy, how do we know the best model out of them? Model M1, M2, M3, M4, all of them have nearby kind of similar accuracies. Out of all those 4 models, which one is the best model? The model which has least information loss. That information loss is calculated by AIC. Then what is BIC? BIC is just a substitute to AIC. It has slightly different formula. We can use either AIC or we can use either BIC. One of them is sufficient, or you can just simply fix to AIC throughout our analysis. So let's do an exercise to understand this model selection procedure. Find AIC and BIC values for our first fiber bits model. We built one model, right, with all the variables. So model 1 is there with all the variables. We will find AIC and BIC. What we'll do is we'll look at top 2 impacting variables, least impacting variables as well. From that model, we will drop the least impacting variables just because that we don't want them. Simply we feel that top impacting variables are sufficient to build the model, and we will not keep the last 2 impacting variables. The least impacting variables we will drop from the model. Then we will build model 2 by dropping those variables. That is model 2 scenario. What we'll do in model 3 is we will we'll go really crazy. We will add a lot of interaction terms. We will add polynomial variables. We'll try everything that is possible to increase the accuracy. Then we have three models, M1, M2, M3. So what is the best model out of these? How to choose? M1, M2, M3, all of them are doing the same task. They are predicting whether a customer will iterate or not. Out of these three models, how do we choose the best model? We have to use model selection technique, that is AIC and BIC values, to decide that. So here is what we are doing. Model 1. Simply model selection. So we have already model 1. For that we are finding the accuracy of model 1. The accuracy of model 1 is 76%. You might have already found that for fiber bits data accuracy is 76% with a threshold of 0.5, right? This is model 1, and AIC BIC values of model 1. The information lost is 97,377, the information loss index. We can look at the summary and variable importance. There is a variable called income, looks like one of the least impacting variable after monthly bill. I'll try to drop income and build model 2. I'm considering everything else. I'm dropping income and then try to fit a model. Is there income here? No, I just dropped it. I'm building model 2 because I feel income is least impacting. I mean, income is not one of the most impacting one. I'll drop income and then find out the accuracy again. I dropped income, built the model. Don't worry about the warnings. It just says fitted probabilities numerically 1 and 0 occur. That's fine. That's just a warning. It can happen. And then find the accuracy of this model. By dropping income, which was one of the least impacting, my accuracy hasn't really affected that much, because accuracy before this model was around this bit only, around 76%. Here also accuracy around 76%. That is model 2. Now what is AIC, information lost, in model 1 and model 2? Model 1 has 98,377 information lost. Obviously model 2, since we dropped one more variable, information loss will be higher. That is true, but we need to see, we dropped a variable and we lost some information. Are we fine with that? Accuracy also at the same level. Maybe if I have to choose between these two models, I'll rather go ahead with model 2. Though information loss is higher, but it is not really lot of information lost, as opposed to, given that one variable I can drop and accuracy is almost same and I don't need to maintain that variable, then I would choose model 2, though information loss is. If by dropping that variable I'm losing out a lot of information, then I'll not choose model 2. Now this time there is a third model that I'm building. What am I doing here? I'm going to do so many things here. This is Y variable remaining all the X variables. I'll keep back income because income dropping or keeping has not much impact. I'll keep back income. I'm also creating new variable, technical issues per month into number of plan changes. I'm creating an interaction variable because I have a gut feeling that technical issues per month and number of plan changes are interlinked. So that's why I'm creating a interaction variable. Speed test result is one of the most impacting variable. I think square of the speed test result, this polynomial term also I want to add, because that has a polynomial impact. If the speed test is failing, that means people have a higher tendency to leave. That's what my gut feeling is. I'm adding those two variables. So by adding some more complication, am I achieving anything in terms of accuracy? That's what we do, right? That's what we try when we are building the model. We want to do several things to increase the accuracy. Now finally, what is the accuracy of the third model? The accuracy of third model is still 76%. No matter what you do, it is lying around 76% only. So you built 3 models and 3 of them you have the information lost. Okay, so you have 3 model with fairly similar accuracy. So model 1, 2, 3, you have 3 models which are serving you the same purpose, that is they are trying to predict whether a customer will stay back in the network or he will leave. They have the same accuracy. Which model is the best one? The one that loses out the least information, maybe third model has least information lost, first model has the second model has the highest information lost, this has the medium kind of information lost. So you have to decide at that level of accuracy, given these number of variables, given this is information lost, which one you want to choose. You can choose the second model depending on the type of problem, depending on the class of the problem, specific business problem. You can use AIC. Sometimes I want to choose model 3 because that is the least information lost and I have captured everything, but only thing it is more complicated than other models. Or maybe I can just stick to the model 1, whereas I will use all the variables, and then information lost is not really high. Or maybe sometimes I'll choose model 2 because that is one variable less and information lost is slightly higher than the first model. That's how you can use AIC and BIC. Basically, when you have more than one model doing there are 3-4 models which are doing the same type of job, you can look at the AIC and you can look at the accuracy, the trade-off between them. Finally, you can choose one model. That's how you can use AIC, and even BIC will also be always consistent with AIC. Don't worry, they never show contradictory results. You can never think of something where AIC is higher, BIC is lesser. It doesn't happen like that. They're almost derived in the same fashion, so both AIC and BIC will be consistent. So you can use either AIC or BIC while choosing the model. BIC works better for a specific class of problems. As of now, you can just focus on AIC.